You're able to see now my screen, right? Hello, Shilpa?
Hello,
Yeah, I'm audible.
you can hear me now, sir? Yeah.
Yes, yes. Yeah, I think that Google Meet, their server has it. Even the link is not free.
Okay, sir.
Yeah. So actually, on the IO programming end, like you are comfortable, right? Now you can create the delays and yeah, toggling and like sending to certain ports and all, right? So I mean, if you see other programs also, it's the same logics they have used. I mean, there is no, I mean, with the different problem statement, almost similar logic. Hope you can manage that.
Yeah, sir.
If you are like having
Yeah,
any
sir.
doubts, you can let me know. Okay. Um,
Yes, sir.
Now today, what we can do, like we can jump into the timer aspects. Okay.
Yes, sir.
Timers, I think like the basics we discussed, right? Architecture. Straight away, shall we jump into problems, the programming exercises?
Can you revise it, sir? Like in a short manner.
Sure. And the same notes what you shared, right? Do you have like other unique notes also from the same professor? Like because here a lot of programming exercises and all that. So if you have any other,
Yeah, sir. I have it. Yeah, I have it.
yeah, you can share me that.
Yeah, like module 4 and 5, I'll share.
Right. So as we know, like why do we need timer? Basically, like in order to count some events or to keep track of time, right? So
Yes,
if you
sir.
consider like, for example, the delay what we had, like 1 millisecond, every 1 millisecond toggle the delay. What we did, we used that like for loop mechanism, right? Like running the for loop for certain duration, and then we will
Yes, sir.
delay this. But actually, many a time, what will happen that mechanism is not a efficient way because whenever you run that for loop infinitely, you are engaging the microcontroller for that much duration. So what happens in between if you get any interrupts, if any operation has to happen in that duration, that will not be allowed, right? So that's where like the timer comes into picture, which actually you can keep running your program parallelly. This timer will keep track of delays and all. Okay. So another example
Yes,
is
sir.
counter. Now let me consider like your speedometer in the vehicle. So in the speedometer in the vehicle, what happens actually whenever the wheel rotates, we have one sensor that is actually which generates some pulses. Okay, so our timer, what it does, it counts the count. I mean, how many pulses we got, so that it will count. So in 1 second, how many pulses we got? Based on that, we will get rotation per minute, right? RPM of the wheel. Based on that RPM, we calculate the speed. So that is one example. There are various examples. how many people enter to the room, like we count them, and how many events occurred, that we count in industrial applications. Okay. So in timer, actually, basically in 8051, we have two timers. Okay, two timers. One is actually T0, the timer 0, another is T1, each of 16 bits. Okay. So our 8051 architecture registers are how many bits? 8 bits. So this is an
8
exceptional
bits.
case. So this is 16 bits. Okay. So whenever you count the timing, so you should be little bit careful that like this doesn't exceed the 16 bit. Like maximum count what I can have is 2 power 16, right?
Yes.
Here maximum count what I can have is 2 power 16. So like for example, every count, like if you are running at, like simple example, like if you are running at if you are running a clock at 1 megahertz, then one count is so this is just example, but like usually there is a lot of clock divider and all. I'll discuss that. 1 microsecond, one count is equals to 1 microsecond. Okay. So then maximum delay what I can have is 2 power 16 into 1 microsecond. This much delay I can have. Hope you got it.
Yes, sir.
Okay. So this 16 bit, right? 16-bit register, we divide into T H, first 8 bit, right? First 8 bit, MSB 8 bit, we refer it as TH, timer high bit. And lower bit, we refer lower 8 bit, we refer it as TL. Okay.
Yes, sir. Yes, sir.
And for, I mean, if it is timer 0, I'll refer it as TH0. Lower byte, I'll refer it as, so actually, if it is timer 0, TH0, TL0, and TH1 and TL1. Okay.
Yes.
Just a minute. So in order to control this timer, right, we have some register called Tmod. I mean, in the sense, like we have various modes of operation, right? And we will be having like various circuitries and all, right? So in order to control that, we have something called Tmod registers. Okay. So and for both the register, for the both the timer, right, we have single register. Okay. So this is basically 8 bits. Tmod register is 8 bit. Okay. So
Yes, sir.
seventh bit of that Tmod register is gate. So we will see what is gate and all. Sixth bit is, I said like two modes of operation, right? Timer or counter. So sixth bit represent whether it is a timer or counter. Fifth bit represents M1, that is mode bit, okay? And fourth bit represents M0. So using M1 and M0, right? we can have 4 combinations: 0, 0, 0, 1, 1, 0, 1, 1, right? So this actually helps us to use 4 modes of operation. Clear?
Yes, sir.
So same way, next to 4 bits, right? That is actually 3, 2, 1, 0. It helps us for next timer. This is for timer 1. Upper 1 is for timer 1. This is for timer 0. But operations are same. Okay.
Yes, sir.
So the gate, right? The functionality of this gate bit. So it basically, we are enabling the timer only when INTX pin is high. We have an INTX pin in the 8051. I mean, there is a dual function
Yes, sir.
pins, right? If you see that INTX pin, so there is one pin. So if that is high, then only the timer will be enabled. Okay.
Yes, sir.
And that INTX pin is high, and TRX pin is TRX control pin also set actually. That there is actually another interrupt control pin. Okay, so that interrupt control pin is enabled, and if this interrupt is high, then only this counter will implement. Okay,
Yes, sir.
so this is clear actually. Whether timer or counter, this we are saying whether it is a timer or counter. Okay,
Don't.
and using this mode, right, we can have 4 mode. So like if it is 0, 0, m1 m0 is 0, 0, then it means mode 0. Okay, mode 0. In the mode 0, our timer, right, so it is actually 13-bit. It will, so we know it is a 16-bit timers, right? But out of that, it will
Yes,
act
sir.
like a 13-bit timer. Okay,
Yes, sir.
in mode 1, it is actually 16-bit timer. Okay, and mode 2, it is actually 8-bit timer, and it also has a functionality of auto reload. In the sense, see, when we have like if I want to operate this timer from 0 to 10, okay, after 10 what happens, it actually stops at that point, right, in the 16-bit mode or 13-bit mode. So in the auto reload mode, what
Yes, sir.
happens, it goes up to 0 to 10, then it again comes back to 0. That kind of auto reload, like automatically it will align. Okay,
Yes, sir.
and last, third mode is actually split mode. In a sense, here we can, so 16-bit timer we have, in that we can use two 8-bit timers. Clear?
Yes, sir.
So here, in order to find what clock frequency the timer is operating, right? So we have to multiply the operating frequency of microcontroller. Uh, be careful here. You should multiply the operating frequency of microcontroller with 1 by 12. Okay. So
Yes, sir.
if I say if my microcontroller is operating at 1 megahertz, then timer will be operating at what frequency? 1 by 12 into
12.
12, correct? So that is 1 megahertz,
Yes.
correct? So so I
Yes,
said,
sir.
in order to find the, please you can note also, in order to find the clock frequency of timer, you have to multiply this by 1 by 12 mega, 1 by 12. So my operating frequency of timer now it is 1 megahertz, right?
Yes, sir.
Okay. So each count corresponds to 1 microsecond. Correct? Agree?
Yes, sir.
Yeah. So same way, if I say if my microcontroller is operating at 16 mega, can you find the time duration of each count?
Yes, sir. 16 into 1 by 12.
Mega. Yeah. Then you have to inverse of that. That is in time, right?
Okay.
That is
Yeah.
frequency. 1 by frequency is time.
Uh,
Correct?
Time. 1 by 2.
Yeah.
0.75.
Right. So we got to know how to control the timer using Tmod, right? Tmod. But so for example, this timer reach certain counts. Or like for example, if I'm using this timer for monitoring some time, 1 millisecond, or monitoring some interrupt, then I need to have some output register also, right? Where I have to monitor. Correct? So for that,
Yes,
we
sir.
have TCON register. So in timer only three important registers. One is actually timer register itself. We have TH0, TH1, TL0, TH1, TL1. That is a timer register, correct? And we have TMOD register. In that, what are the bits we have? Gate, timer hour counter,
Time.
mode 0, mode 1, and again for
M1.
same thing like LSB again for the another timer, correct?
Yes, sir.
Same way, we have TCON register, timer control register. Okay. In that, the MSP is TF1, TR1, TF0, TR0, IE1, IT1, IE0, IT0. Okay. So TF1 is actually timer overflow flag. Okay? Timer overflow flag. Okay. So if this, whenever this set to 1, right? It means actually timer is rolling from maximum all 1 to all 0. It will be, actually it's output, right? So it will set to high whenever it is rolling from all 1 to all 0. All 1 means actually what? FF, right? FF.
Yes,
Uh,
sir.
you can think of in this way. So the timer starts from 0, right? It's 0, 1, 2, 3, and it reaches to maximum what value it can reach. All 1, right? FF. That is 256. Correct?
Yes, sir.
After 256, we don't have bits, right? So it has to roll back
Yes.
to 0, correct?
Yes, sir.
During that rolling back, this TF1 will be set. Got it?
Yes, sir.
Yeah. So TR1, right? TR1, actually, if you want some control from the program itself. So if you want to have some kind of stopwatch kind of application where you will start the timer and you will end the timer. Okay, if you want that kind of application, you can use TR1. So whenever TR1 is high, your timer will be keep counting. Whenever TR1 is low, you will stop the count. Okay.
Yes, ma'am. Yes.
Same way TF0, TR0 for the other uh, counter or timer. Okay. So IE1, right? IE1, it is actually interrupt flag. Okay. So actually, we have discussed, like, we have an interrupt pin, right? So whenever you received some interrupt, okay, uh, in the interrupt pin, then this bit will be set high. IE1 will set high. If you receive any interrupt, right, this bit will be set high. That is actually high to low edge. If the signal is high, suddenly you make it low, then this bit will be set in the interrupt pin. Okay.
Yes, ma'am.
So IT1 is external interrupt enable pin. Okay. It is actually set to 1 by, I mean, if it is like, if you want external interrupt enable, so if you want to, like, based on, if you want to count, if you want to use the timer in counter mode based on external interrupt, then you have to set this IT1. Okay. This IT1 is called external interrupt enable. Clear?
Yes, sir.
Okay. So now, while programming also, we should keep in mind in which mode we are programming. Correct? Like, we have 4 modes. So in the problem statement also, whenever they give problems to write a program, you should be careful in which mode you are writing. So first mode is mode 0. Okay.
Yes, sir.
Mode 0, how many bits timer actually? It is 16-bit timer, right?
That,
Which we operating 16-bit timer.
sir, you said 13-bit.
Sorry, it's a 13-bit. Mode 0 is 13-bit. Okay. Mode 1 is actually 16-bit. Okay. So frequently, like, we use mode 1. Mode 1 is actually 16-bit because we get a complete 16-bit of operation. Like, we cannot, actually in mode 13, it's a exceptional cases, like, where we want like very short duration. Mode 1 is actually 16-bit timer where we actually like have like complete 16-bit usage. Mode 1 is 16-bit. Mode 2 is actually how many bits?
8-bit.
Correct. Mode 3 is a dual split bit, right?
Yes, sir.
Yeah. So when I say 16-bit, how many? What are all the values it allows actually? It allows from 000 to FFF. Correct.
FF. Yes, sir.
So whenever we want to load some initial value, I mean, see, now actually whenever I am giving from 000 to FFFF, so it takes that many count to reach that. See, actually we saw that one overflow TF1, right? So TF1, whenever TF1 toggles, that means I reach that count, right? So basically, timer basic idea is uh, we have to how long we took to reach that maximum value. Okay. Now, if I want 1 millisecond delay, what I do, I will load the initial value from where to count, right? With that much, like maximum minus how many counts I require to reach that 1 millisecond. That many value, right? I will load here. So your counter will load from that initial value to maximum. You're getting idea?
Yes, sir.
See, actually, let me consider with a small count. If I take from 0 to 1 count, 0 to 10 count, 1 millisecond, okay? Uh, Okay, 10 millisecond. Let me assume I'm taking from 0 to 10 count. I'm taking 10 millisecond of time. Okay, so that is my timer. You assume it's a small time. Huh? Now, if someone asks, give me a logic for generating 1 millisecond, then what I have to do? Like, I just need to toggling, right? From 9 to 10 count, it takes 1 millisecond. So whenever 10 overflows, my overflow flag will be set. So what I'll do, initial value I'll set to 9. So counter will be keep toggling 9 to 10, 1 millisecond. Your timer flag will be set. Again, it will 9 to 10, 1 millisecond. Timer flag will be set. Same way, if I want 5 millisecond count, what will happen? I'll load initial value, I'll load with 5. So 5, 6, 7, 8, 9, 10. Whenever 10, your timer flag will be overloaded, like TF flag will be overloaded. So 5 millisecond reference.
Yes, sir.
You're getting idea?
Yes, sir.
Yeah. So actually, that initial value, what you want to load, right? So you have to set TH0 if you are using timer 0, TH0 and TL0, whatever the initial value you want to load, right? Will be loading to these two registers. Okay.
Yes, sir.
So basically, what we will be doing in the program, we have to keep monitoring which bit, TF0, correct? TF0.
Yes.
So whenever TF0 is high, it means it reached the timer. Okay.
Yes, sir.
So whenever it reaches this much duration, right? TF0 and TL1, it reached TH0 and TL0 reached that duration. Next step, TF0 is set, right? Now what you have to do? You have to do CLR TF0, and again you have to move TH0 with the initial value. Maybe if I say hash 55, move TH1 with hash 33, something like this. Okay,
Yes,
clear?
sir.
Based on the
Yes, sir.
count how many counts we want. So see, again, how to find the count, right? How to find the frequency is basically based on that one microsecond we discussed, right? 1 by 12 into your clock frequency. So usually they'll mention the clock frequency of 8051. Okay. So based on that, you have to see like one count is how much delay. Okay. You have to find how much delay. Then what you have to do? You have to, for example, if I want some 12 microseconds, so I need 12 count, right? Then what you have to load to timer actually? It's not 12. You have to load 255 minus 12. Correct?
I didn't understand, sir.
Okay. Now, clock frequency 1 by 12 into clock frequency, I'll get one clock. I mean, again, whole you have to inverse it. So you will get the time of one cycle, right? One count, like one
Yes, sir.
microsecond for 12 mega. We found 1 microsecond, right? There, that time, correct?
Yes, sir.
So now if someone asks you, I want 12 microsecond delay, then I need 12 count, right? 12 such count.
Yes, sir.
Correct. This much you are clear?
Yes, sir.
Yeah. So we are monitoring TF flag. That means actually whenever it rolls out, all f to all 0, correct? All f to all 0, 0, 0. That time we get actually the TF flag set, correct?
Yes, sir.
Now, every 12 count, we have to set the TF flag because to get the 12 microseconds.
Yes, sir.
That point you have got, right?
Yes, sir.
So if I roll out from 0 to FF, then I mean, if I initialize timer with 0, 0, 0, then after FFFF count, each FFFF count, it will roll out. But I want after every 12 count, it should roll out. So what I have to load? I have to load FFF minus 12 to the timer. So that what happens? FFF minus 12. So it will actually what happens? Just 12 below the FFF. Okay? So it will counter will reach in 12 count, this FFF, correct? Timer will
Yes, sir.
reach in 12 count maximum value. Then we will get that 12 microsecond delay. You're getting?
Yes, sir.
Got it, right? It's a simple funda. So that time I gave
Yes, sir.
one example like 10 millisecond. Each count gives 1 millisecond. If I want to have 2 millisecond of delay, I have to load 8, right? Because 8, 9, 10. So it became 2 millisecond and your timer will overflow. Again, 8, 9, 10. I should not load 0. I should load 10 minus how many count delay I want. Like maximum minus that much. So here maximum is
Yes,
FFF.
sir.
Minus 12. That load, that count I have to load. Okay.
Yes, sir.
Okay. FFF minus 12 plus 1 it is. Okay. Because what happens like whenever it doesn't reach FFF, like as soon as it reaches FFF, it suddenly overflows. So minus 12 plus 1 you have to do. This is the formula actually. Okay.
Okay, sir.
Okay. So today I'll pause for today. Maybe like evening I'll take another session around 30, 40 minutes because like now I have to go to office. I'm in Bangalore.
Okay, sir.
Today I have
No
come
problem.
to Bangalore for some work. Okay.
At what time, sir?
Maybe post 7:30. Hmm?
Sure, sir.
Okay.
Okay, sir.
Till what time you will be available actually? Uh,
You can take at 9 also, sir. Night. No problem. I'll join.
okay.